Hello everyone. In this video we'll solve questions 51 to question 60 from chapter 1 making measurement. Let's look at question 51. Metal ball is attached to a cork and is lowered into a measuring cylinder. Pulling the cork into the water as shown. The mass of cork is 4.8 gram. What is the density of the cork? Now, to find the density of this object, we need to find what's the mass and what's the volume of the object. So usually these methods are used to find density of objects which floats on liquids. So usually this object would float on liquid, so we attach something which is heavier so that it sinks, something which is higher density, and later we can find the volume of this object. Now, so this question is a little deceptive because they have given us this 48 cm cube of water initially. After dipping the ball, the volume becomes 56 cm cube. Then after dipping the ball and the cork, the volume becomes 80 cm cube. They are asking us what is the density of the cork. To find the density of the cork, we need the mass of this cork, that would be 4.8 grams. We will also require the volume. So the volume of the cork can be found out using these two diagrams. So in this diagram, diagram 3, right, the cork is completely immersed in the liquid. In diagram 2, it is not immersed. So by immersing the cork, the volume has raised by some value. That change in volume would itself become the volume of the cork. So volume of cork will be 80 minus 56. That's 24 cm cube. To find the density, we have to use the formula mass over volume. This is 4.8 divided by 24. So we have to open our calculators. So here we'll type 4.8 divided by 24. That's 0.2. So the density of this object is 0.2 and the units are gram per cm cube. So the correct answer is option B, 0.20 grams per cm cube. Let's look at the next question. A rectangular metal block is 20 centimeter long. The cross-sectional area of the block is 25 centimeter square. The mass of the block is 4000 grams. What is the density of the metal? So here we have been provided with the mass of the block, which is 4000 grams. We don't have to convert it into kgs because all our options are given in terms of grams per cm cube. So let's keep this in grams itself. We have to find what's the volume. This is unknown to us. The options in our question, they have given us what's the area of cross section. Let's say if I have a cuboid, if I want to find the volume of the cuboid, and if I am provided with length and area of cross section, remember that this area of cross section times length will give us the volume of the cuboid. In another sense, if you want me to further continue with this, let's look at this. This area here, let's say there is breadth here and height here. This area is given by B times H. The area is B times H. And if I multiply this with length, so length into area will become L times B times H. That would be the volume of the cuboid. So when you want to find the volume of the cuboid, remember, if you have cross-sectional area times height, or cross-sectional area times breadth, or cross-sectional area times length would give us the volume of the cuboid. So in our case, this volume will be equal to 20 times 25. Again, let's use our calculators. (20 times 25 is 500. So the volume is 500 cm cube. Now the density is given by mass over volume. 4000 divided by 500. So let's use the calculator. 4000 divided by 500, that will be 8. So the answer is 8 grams per cm cube. So the correct option is option C. Question 53. A square wooden raft floats on a lake. The density of the water in the lake is 1000 kg per meter cube. The sides of the raft are 2 meter long and the thickness of the raft is 0.2 meters. The mass of the raft is 700 kg. How many barrels, each of mass 1000 kg, could be placed on the raft before its surface sinks to the surface of the water? Alright, let's take up this question. So in the question they have provided us that there's a raft and it's a square raft. So its length and breadth are 2 meters each and it has a thickness, right? The thickness of this raft is 0.2 meters. Now, the mass of the raft is 700 kg. So if I have to find how many barrels can be fitted onto this raft, I have to find what's the density of the raft first. Let's write down the data. Mass is given to us 700 kilograms. Volume can be figured out. Volume of this raft will be 2 times 0.2. So basically length times breadth times height. So let's use our calculators to find this. Times 2 times 0.2, the answer is 0.8. The volume is 0.8 meter cube. Let's find the density of the raft. The density of the raft would be equal to 700 divided by 0.8. Now 700 by 0.8, that's 875. Alright, so the density of the raft is 875 kg per meter cube. Let's look at this. The density of water is 1000 kg per meter cube. The density of the raft is 875 kg per meter cube. Obviously the raft is less dense compared to water, so the raft has to float. If I have to find how much mass can be added onto the raft to make it at surface level with the water, let's look at the mass of the raft. The mass of the raft is 700 kgs, and each barrel has a mass of 100 kg. So if I add 100 kgs onto it, the total mass becomes 800 kgs. So the total mass is 800 kg with the barrels. So imagine I have put a small barrel here. It's only one barrel and that has a mass of 100 kg. So the mass now becomes 800 kg, but the volume of the raft doesn't change. The raft still has the same volume of 0.8 cm cube, so 0.8 meter cube. So mass of the raft with one barrel is 800 kg. Now if I have to find density of raft along with one barrel, that would be equal to 800 by 0.8. 800 by 0.8, let's use our calculator. 800 divided by 0.8, that's 1000. Now the density of the raft becomes 1000 kg per meter cube. This has the same density as water. So now it will be, the raft will be at the surface level of water. If I add any more mass into the raft will sink. So the maximum number of barrels that can be added to this raft will be 1. So the answer is option A. Question 54. A student is asked to predict whether a solid floats in a liquid. Which information does the student require? The density of the liquid and the mass of the solid, that's not needed. The density of solid and the density of liquid, this information is needed for us, because if I know the density of solid, depending on whether the solid has a density larger than liquid or less than liquid, I can predict whether it floats or sink. Question 55. The mass of a measuring cylinder is 190 gram. 400 cm cube of liquid is put into the measuring cylinder. The total mass of the measuring cylinder and the liquid is 560 grams. 4 solid objects are lowered in turn into the liquid. The densities of the objects are shown. Which object will float in the liquid? So in order to find out which object floats in the liquid, we have to find out what's the density of the liquid. In order to find the density of the liquid, we need the mass of the liquid added and we need the volume of the liquid. Mass of the liquid is pretty simple to find. So here, before adding the liquid, the mass was 190 grams, and after adding the liquid, the mass of the measuring cylinder and the liquid was 560 gram. So the mass of the liquid alone will be 560 minus 190. So 560 minus 190 is 370. 370 gram will be the mass of the liquid. Now let's figure out what's the volume. Volume of the liquid is already given to us in the question. It is 400 cm cube. So the density of liquid will be mass over volume, 370 over 400. Again, let's use our calculator to find this. (370) divided by 400, that's 0.925. So the density of the liquid is 0.925 and the unit is gram per cm cube. Let's look at the density of all the other objects. Now we have the first object. First object has a density of 0.4 gram per cm cube, and we have to find which object floats. And obviously object 1 has less density compared to the liquid, so object 1 floats. Object 2 has a density of 0.9 gram per cm cube, which is again less than the density of liquid. Object 2 floats. Object 3 and object 4 has density larger than the density of the liquid, so both of them will sink. So these two will not float. So the correct answer is object 1 and object 2 floats. option will be option B, 1 and 2 only. Question 56. Water has a density of 1000 kg per meter cube. A rectangular swimming pool has average depth of 1.6 meters. The length of the pool is 25 meters. The width of the pool is 10 meter. What is the mass of the water in the swimming pool? In this question, we have been given with the length of the pool. Length is 25 meters. The width, which is the breadth of the pool, which is 10 meter, and the depth or height of the swimming pool. So the depth will be 1.6 meters. They have also given us the density of water. Density of water is 1000 kg per meter cube. We have to determine what is the mass of water in the swimming pool. Now, so let's find out volume. Volume is length times breadth times height. That's 25 times 10 times 1.6. So 25 times 10 times 1.6, it's 400. The volume of the swimming pool is 400 meter cube. So density from the formula is given by mass by volume. If I want mass, if I take it as subject, mass can be written as density times volume. This will be 1000 times 400. That will be equal to 400,000 kg. Correct option is option C. Let me recheck with the volume of this. So the volume is it's 25 times 10 times 1.6, 400. Alright, so our answer is correct. Let's look at question 57. A rectangular gymnasium is 50 meter long, 25 meter wide and 8 meter high. The density of air is 1.2 kg per meter cube. What is the best estimate of the mass of air in the gymnasium? So to find mass, we need density and volume. First, let's figure out the volume. Volume is given by L times B times H because it's a rectangular gymnasium. It will be 50 times 25 times 8. It's 10,000. 10,000 meter cube is the volume of the gymnasium. In density is mass by volume. Taking mass as subject, we can write mass equals density times volume. Density is 1.2 kg per meter cube. So 1.2 times 10,000. 1.2 times 10,000 is 12,000. So the mass of air in the gymnasium is 12,000 kg. Correct answer is option D. Question 58. A measuring cylinder contains 40 cm cube of water. A solid metal ball is dropped into the water and the water level rises to 56 cm cube. The mass of the ball is 80 gram. What is the density of the metal from which the ball is made? So we have to find what is the volume of the ball. So the volume of the ball is given by the final volume of the liquid in the measuring cylinder minus the initial volume of the liquid in the measuring cylinder. So here the final volume was 56, that's after immersing the ball, and before immersing it was 40. So the volume of the ball is 16 cm cube. Now to find density, we'll use the formula density equals mass over volume. This will be 80 over 16. 80 over 16 is 5. So 5 gram per cm cube. Correct answer is option D. Question 59. The density of air is 1.2 kg per meter cube. A room has dimensions 5 meter times 4 meter times 3 meter. What is the mass of the air in the room? So here let's write down the given data. So we know density is 1.2 kg per meter cube, and now we have to find the mass. So we need the volume. Volume is simply given by length times breadth times height. So 5 times 4 times 3. So 5 times 4 is 20, 20 times 3 is 60. So 60 meter cube is the volume, and from the formula density equals mass by volume, we'll write mass equals density times volume. This will be 1.2 times 60. Let's use calculator for this. One 1.2 times 60 is 72. So let's write down M equals 72 kilograms. Correct answer is option D. Question 60. The table gives the mass and volume of 3 objects P, Q and R. Which objects can float in a liquid of density 0.85 gram per cm cube? So to know which object floats, we need to find what are the densities of each of these objects. For the first object, so density of object P will be equal to mass over volume. Let's use calculator for this. So mass of object P is 23 and the volume is 36. 23 divided by 36 is 0.638. So let's call it 0.4. Sorry, not 0.638. So we can call it 0.64. So this will be 0.64 gram per cm cube. Next we'll find out what is density of object Q. Density of object Q is 170 upon 720, that's 0.236. let's call it 0.24. 0.24 gram per cm cube. Then density of object R will be 240 divided by 340. So 240 divided by 340, that's 0.7058, so we can call it as 0.71. This will be 0.71 gram per cm cube. Now, in order to find which object floats, the density of the object should be less than the density of the liquid. So let's look at all these three objects. The density of all these objects are less than 0.85 gram per cm cube, which means all the three objects will float on this liquid. So the correct answer is option D.